Hello everyone, you are welcome to this lesson. In this video, you are going to solve this question I have here. The question says two forces are applied as shown to a hook support. Knowing that the magnitude of P is 35 newtons, determine by trigonometry A. The required angle alpha if the resultant R of the two forces applied to the support is to be horizontal, and B. The corresponding magnitude of the resultant force R. So let's look at how we are going to solve this question. So I'm going to start by drawing the free body diagram. Okay, so let's look at that. Okay, so let's take this to be the hook. Okay, we have our x and then the y axis. Okay, so I will go ahead and then draw the first vectors. Okay, so let me draw the 15 newtons force. Okay, so let this be the 15 newtons force. Okay, and then we know that the resultant force is going to be horizontal. Okay, so that means that it will lie on the x-axis. Okay, so let me just draw the resultant force now. Okay, so this is the resultant force. Okay, and then let me draw the force P, which is the 35 newtons. So let this represent the 35 newtons. Okay, so let me name them. This is the 15 newton force. Then we have this to be the 35 newtons. Okay, let me write it here. Okay, so now what I'll do is that I will draw a force vector to be parallel to the 15 newtons. Okay, I think that's a little short. Okay, so let me redraw this. Okay, then let me draw this to be parallel to the 15 newtons, and then I'll draw another to be parallel to the 35 newtons. Okay, let's take note of that. So this is the 15 newtons, then this is the 35 newtons. Okay, we are going to have another 15 newtons here, then we will have another 35 newtons here. Okay, so we know that the 15 newtons makes an angle of 25 degrees with the horizontal. Okay, and then the 35 makes an angle of what? Alpha, which is the angle we have to find now. Okay, so what you have to know is that this angle here will also be 25 degrees because you're going to have an interior alternate angle there. Okay, so here is also going to be 25. Okay, because you're going to have some z angles here. Okay, so this is it. So if here is 25, here will also be 25. Okay, so with that angle we can find the value of what? Angle alpha using the sine rule. Okay, so let's look at that. The angle alpha is opposite the 15 newtons, and then this 25 is opposite this 35 newtons here. So we are going to have sine of alpha divided by the 50 newtons. Okay, equals the sine of 25 degrees. Okay, the sine of the 25 degrees divided by what? 35 newtons. So at the end, you're just going to have sine alpha equals sine 25 divided by 50. Okay, multiplying the, sorry, sine 25 divided by 35 multiplying 50. Okay, so let's simplify this and see what you are going to get. So let me punch the sine 25 divided by 35 and then multiply by the 50. That gives us a value of what? 0.6. Okay, so we're going to have sine A equals 0.6, and then sine alpha, and then alpha, okay, will be equal to the sine inverse of 0.6. So let's find that value and see. So sine inverse of 0.6, okay, will give us a value of 37.14 degrees. So that will be the angle that the 35 newtons will be making with the what? X axis. Okay, so with the value of this angle, we can find this angle here, which is the angle opposite the resultant force. Okay, this is the resultant force. So we can find this angle here. Let's name it theta. Okay, which is the angle opposite the resultant force. Okay, and then if you know the value of that angle, we can use the cosine rule to find the resultant force. Okay, so now let's go ahead and then find the angle theta. Okay, so to find theta, you're going to have 25 degrees plus angle alpha, which is 37.14, okay, plus theta. All that should give us what, 108, right? Because the sum of the angles in the triangle should be equal to what, 180. So we now solve for theta. So we're going to have theta to be equal to 180, sorry, 180, okay. Let me just bring the degrees. 180 degrees minus 25 degrees plus 37.14 degrees. Okay, so let's simplify this and see what you're going to get for theta. I'm going to punch everything at once. So we have 180 minus 25 degrees, okay, plus 37.14 degrees. So that will give us a value of 117.86 degrees. So that will be the angle opposite to the resultant force. Okay, so now that we know the angle opposite the resultant force, we can use the cosine rule to find the value of the resultant force. Okay, so we're going to have r squared to be equal to, we know the two sides, which is the 35 newtons and then the 50 newtons. So r squared will be equal to 50 squared plus 35 squared, okay, minus 2 multiplying 50 times 35, okay, cosine of 117.86 degrees. Okay, so let's simplify this and see what you are going to get. So let's find the value of 50 squared plus 35 squared. That gives us a value of 3725. Okay, minus, let's find the value of 2 multiplying 50 times 35. Okay, cosine of 117.86. So that gives us a value of minus 1635.59. Okay, so at the end you will have to add these two values. So let's look at that. So we are going to have 3725 plus 1635.59. So let's simplify this and see what you are going to get. So 3725 plus 1635.59. That will give us a value of 5360.59. So let's find the square root of this value. So the square root of 5360.59. Let's see what you are going to get. So the square root of that value give us 73.22 newtons, which will be the value of the resultant force. Okay, so at the end that will be the value of what? Of the resultant force. So you see that in this case there will be no need for us to find the angle that the resultant force makes with the x-axis, because the resultant force is already lying directly on the x-axis. Okay, so we just have to find the magnitude. Thank you very much for watching this video. Please like the video, and then if you are new to this channel, kindly subscribe to the channel. Thank you.